going to run through how to derive the amortization formula using the sum of a finite geometric series formula. So this come up on the 2017 paper 1 question 8a. So if you look at that question, you'll see the exact wording they put on it that year. But it's using the formula for sum of a finite geometric series, derive the loan repayment formula. So loan repayment formula is the loan repayment is equal to the amount you borrow multiplied by I on 1 plus I to the t over 1 plus I to the t minus 1. So P being the loan amount, A being the repayment, I being the interest rate as a decimal, and T being the number of repayments, and then it specifies in that question, and it should specify that the repayments are made at the end of each period. So using the formula for the sum of a finite geometric series. So we are going to form a finite geometric series first, and then we'll sum it, and then we'll see what we need to do to derive this. So when we look at loan repayments as a geometric series, it is the amount we borrowed, so that's P in this case, is equal to the repayment, so A is the repayment here, discounted by the interest rate. So the loan amount is the present value of all repayments, okay, added together. So that first repayment happens at the end of the first period, so it's discounted once. Then in another, say, month's time or whatever it is, I make a repayment, and it's discounted twice because it happens at the end of the second month. And then another repayment, and it's discounted 3 times until the last repayment at the end of the final period is discounted T times, however many years or months or whatever we have the loan for. Okay, so the loan, so the amount we are borrowing is equal to the present value of all future cash flows added together. Okay, so you've got a geometric series there. So there's your A. So your first term is A over 1 plus I. And what are you multiplying by to get from term to term? It's 1 over 1 plus I. So the top is staying the same, so that's just going to be 1. And the power on the 1 plus I is increasing every time. So your OR is 1 over 1 plus I. So it gives us the prompt to use the sum of a finite geometric series formula. So Sn is equal to A on 1 minus OR to the n over 1 minus OR. So let's just slot these into the formula. So it's equal to my first term, A over 1 plus I on 1 minus 1 over 1 plus I. For me, it's T repayments, so my period is T in this case, over 1 minus OR. So over 1 minus, and my OR is 1 over 1 plus I. And then this should add to the amount that I am borrowing, so the loan amount, which is P in this case. Okay, so I'd say your first kind of tranche of marks there are for establishing the series, writing down the formula, subbing into the formula then correctly is going to get you a rake of marks. Okay, so what we need to do now is make this look like this. So turn this into that amortization formula. So this formula here is derived from this. So let's look at this. So this formula is expressed in terms of A. So what I want to do here is get A on its own. So that's going to be the final line is going to be A equals something. So I want to get rid of this 1 plus I from underneath the A. Okay, so I want to get A on its own. It's not a fraction in this formula. So if I multiply the top by 1 plus I, it will get rid of that. And then what I am going to do is multiply the bottom by 1 plus I as well. So I multiply the top by 1 plus I to get rid of this. And then because I multiply the top by 1 plus I multiply the bottom by 1 plus I as well. Okay, and what that is going to, the reason I'm able to do that, okay, just to one side of the equation is because 1 plus I or 1 plus I is just 1. Okay, it's something over itself. Anything over itself is equal to 1. So I'm just multiplying by 1 here, but by doing it in this kind of way here, it's going to get rid of this fraction for me. It's going to get A on its own, or not on its own, so we multiply by this, but it's going to get rid of the fraction anyway. And yeah, so just if you kind of remember, it's to get rid of that 1 plus I and then do the same to the bottom as well. So multiplying the top here by 1 plus I is just going to get rid of this. Okay, so because the entire top is multiplied by each other, you can just cancel this with this, and then the bottom. So let's see if I write this out again. So P is equal to A on 1 minus. One thing I'm going to do here as well. So this is 1 over 1 plus I to the power of t. Okay, when you're raising a fraction to some power, you can raise top and bottom to the power. So for example, like 2 over 3 squared would be 4 over 9. It will be 2 squared over 3 squared. The power belongs, I guess, to the top and the bottom of the fraction. So if I do that, if I bring the t inside the bracket, 1 to the power of t is just equal to 1. Okay, anything to the power, or 1 to the power of anything is 1. So if you bring the t inside, 1 to the power of t is just 1. And then on the bottom, it's going to be 1 plus I to the t. So that's the top. I'm doing two things there. I'm multiplying this in, and then I'm moving the t into the bracket. On the bottom then, 1 plus I multiplied by 1 is just 1 plus I. 1 over 1 plus I multiplied by 1 plus I. Well, the 1 plus I and the 1 plus I cancel there. You're multiplying a 1 plus I by something over 1 plus I, so you're just left with the minus 1. And on the bottom then, you've got 1 minus 1. So that's 0. So they're gone. So you're just left with I on the bottom. It's starting to look a little bit closer to what I want. You see I've got 1 plus I to the t, which I've got in the formula. I've got an I, I've got a P, I've got an A. I'm maybe missing a term or two from the formula, but we'll sort that out in a minute. So next thing I'm going to do is, so it's everything here is over I. So if you look at this formula, while I write the P kind of out on its own, like if you multiply a whole number by a fraction, it belongs to the top. So you could write this formula with the P on top. So P multiplied by I multiplied by that. So this is divided by I. If I move it over, it's multiplied by I. So I have P multiplied by I, which is in my formula. So bring that I over. So P multiplied by I is equal to A on 1 minus 1 over 1 plus I to the t. Now, kind of getting there. So there is a couple of different ways of approaching this. You'll see this derivation done a couple of different ways in a couple of different places. What I'm going to do is I'm going to isolate the A here, because that's what I want. Okay, so I'm going to bring this multiplied by 1 minus 1 over 1 plus I to the t over to either side, and it'll become divided by. So I'll do that here. So pi. So bringing this over to the other side, it becomes divided by 1 minus 1 over 1 plus I to the t is equal to A. So I've got my A, I've got my P multiplied by I just have a little bit more to sort out. So what else have I got? Well, if you look, I should have a 1 plus I to the power of t up the top. That's all that's missing from up the top. So why don't I multiply the top by 1 plus I to the t, because that's going to give me what's missing from the top. And then if I multiply the top by 1 plus I to the t, I'll do the same to the bottom. Basically the same thing I did up here. I kind of looked at what I needed up the top, and then so that I'm only multiplying by 1, I multiply the bottom by the same thing. But if you look, if you multiply the bottom by that same thing, 1 multiplied by 1 plus I to the t is going to give me this, minus, and then the 1 plus I to the t is going to cancel with this, so it's going to leave me with my minus 1. So this is going to give me my formula. So P multiplied by I multiplied by 1 plus I to the t over multiplying the 1 plus I to the t in. 1 plus I to the t by 1 is 1 plus I to the t. 1 plus I to the t multiplied by 1 over 1 plus I to the t. The over 1 plus I to the t and the 1 plus I to the t that you're multiplying by cancel, and you're just left with the minus 1. And that's equal to A. A little bit more space there. But that's my formula, so I might just bring the P out in front like it is in the actual formula and kind of swap the sides so it looks exactly like that, but that's my derivation done. A is equal to, bring the P out in front, on I on 1 plus I to the t over 1 plus I to the t minus 1. So that's my derivation done. Okay, so figure out your geometric series first. So amount that you are borrowing is equal to the loan repayment discounted by your interest rate plus the loan repayment in another month's time discounted by the interest rate squared, etc. Okay, that's a geometric series. Pick out your first term and pick out what you're multiplying by to get from term to term, your OR. Plug that A and that OR into that geometric series formula, as it tells you to do. A little bit of work to do there. So first step is realizing you want to get rid of the 1 plus I under the A, so multiply by 1 plus I over 1 plus I. Bring the I over, then realize that you bring what you're multiplying by there over, and then at this stage here realize what you're missing from the formula is a 1 plus I to the t on top, so multiply top and bottom by that and you'll end up with your formula. Okay, as I said, you can kind of find that done a couple of slightly different ways getting the same result. So if you want to look up some other methods and you prefer them, fire away, whichever one you find easiest to learn.